Normalization is the process of minimizing redundancy from a relation or set of relations to avoid data loss during database manipulation down the road. Given a set of functional dependencies, you may be asked to identify whether a given relation is in second or third normal form. In this video, we will go through the core concepts needed to answer such questions, as well as do some examples of our own. To start, it is important to understand what is meant by functional dependency. Here's a formal definition, but a more intuitive way of thinking about it, especially if you're a math person, is to remember functions, which, if you recall, just says that for each x there exists a unique y. Here, two different x values map onto the same y, so this example is not a function. In databases, this means that each instance of the set x always infers a single unique set y. There are three subcategories of functional dependencies that we must familiarize ourselves with. Also, please note that throughout this video, when we refer to a key, we mean any and all keys. So that could mean a primary key, a candidate key, super key, or foreign key. A functional dependency, y to z, is full if you cannot afford to remove any attribute in the set y to determine z. For example, the proposed functional dependency here, SSN project number to hours, is full, since neither SSN nor project number alone can determine the number of hours an employee worked. Partial dependencies exist when removing an attribute from the left-hand side does not break the dependency of the right-hand side. The attribute whose removal is not fatal to the dependency is the partial one, in this case, project number. Here is a formal definition of transitive dependency. It sounds pretty complicated. Understanding transitive dependency is important because the third normal form does not allow for it. For our intents and purposes, when checking if a relation has a transitive dependency, you just need to check that for each FD you are given, either the left-hand side is a super key or the right-hand side is a prime attribute, or both. Remember that a non-prime attribute is an attribute not part of any key. An even simpler way to check is to see if you have any dependencies from a non-prime to another non-prime. If so, the relation is not in 3NF. Here, as well as for the rest of the video, it is important to know that each successive normal form encompasses the previous, as in every relation in 3NF must first be in 2NF. The first normal form is not the focus of this video, and it is assumed you already know it before watching this. The second normal form forbids partial dependencies. The third normal form states that all attributes of a relation must depend on nothing but the key. This means that a non-prime attribute cannot depend on another non-prime attribute. Let's look at an example of a relation and see if it is in 2NF. You may be given a question like this with a table where you need to infer dependencies that may exist yourself. We see that a student can take many courses, so UCID cannot determine course number. Course fee alone cannot determine course number or UCID. Course fee together with UCID can also not determine course number. Course fee together with course number cannot determine UCID. So course number and UCID is going to be our only candidate key, since it can tell you how much a student paid for a particular course. Now we need to check whether or not partial dependencies exist by checking to see if any non-prime attribute, in this case just course fee, depends on either half of the candidate key alone. We see that course fee depends on course number. This is not in 2NF, since there is a partial dependency. Now let's look at another example. Given the following table and functional dependencies, we see that no partial dependencies exist, since the only key is the UCID, so this is in second normal form. However, salary is dependent on course number, which is non-prime, and so this is not in the third normal form. I hope you find these tips helpful. Thanks for watching.